our old constant, times the concentration of A raised to the power of X, times concentration of B raised to the power of Y.
Okay, I gotta do
The X and the Y.
Yeah, that.
We'll get to that. Next. This is a little bit confusing, but the reaction is X order in A.
So,
For the most part, our exponent will be whole numbers. So if this were 1, we would say it's first order in A.
it's gonna be.
We're going to get to that.
That's what you were
I'm
talking
gonna-
about earlier with the x minus 1, that'll tell us that it's first order.
It can, yes. The units of our K can tell us if it's first order,
Okay.
or second order, or third order. We'll get to it. Okay? The reaction order is determined experimentally. We're going to look at some experimental data in a little bit, then I'm done talking to you and we're going to do some work. Okay? The reaction is Yth order in B. They could both be 1s. It'd be first order in A, first order in B. Click again. And it would be, if they were both 1s, it would be second order overall.
Okay, so what does order mean? Are you getting?
I'm getting there.
Okay.
It has to do with how the concentration affects the rate. Okay? Click. Here we have some data. And we have 3 trials here. We did this trial once with the fluorine concentration being 0.1 molar and the chlorate concentration being 0.01 molar.
Okay.
Okay? And we got a rate. We measured it. This is done experimentally.
So, what is the, what's an example of the experiment that we do to get the rate?
I'm sorry, what?
What's an example of the experiment that we do to get the rate?
Right here. This is how we're going to determine the rate order. Looking at this data, we're going to determine the rate order.
And what do they do to collect the data?
Huh?
What's an example of something that we do to be able to collect the data?
That's a good question, because on a lot of reactions, it's hard to measure the change in concentration, especially when you've got something in aqueous solution. I'm going to have you do a lab where you measure the rate by graphing how fast gas is released from a reaction. You're going to have a reaction occur, gas is going to be given off, you're going to measure the pressure. You're going to stop the gas from getting away and measure the change in pressure. At the beginning of the reaction, a lot of gas is formed, so the pressure goes up really fast. And as the reaction slows down, the change in pressure decreases. And you're going to graph it, and you're going to figure out the rate.
Okay.
Does that answer your question? Something just occurring in aqueous solution, a bunch of ions floating around, that's tough. It's tough to measure rate.
But now we use the, what's it
Huh?
called?
Yeah, you can do it with that too. You can graph it. You use the colorimeter and change it. You can measure, you can graph it over time, and you can measure the change in concentration. Good example. Somebody's thinking. Maybe you don't quit turning in your homework. Yes. Okay. So can you see we did this reaction 3 times?
Yes.
And we changed the concentrations each time. All right. Y'all have a calculator handy?
Yeah.
Get out your calculators. All right, you ready? Take a look at the first trial and the third trial for me, please. Going from the first trial to the third trial, this concentration did not change, did it?
No.
So anything that affected the rate is due to the change in concentration of the F2, right?
Yeah.
There's no change in concentration here. So my concentration of F2 from the first trial to the third trial did what?
It's
Increased by 0.1.
And that is a factor of 2. We doubled the concentration. That's a factor of 2. This one is twice as concentrated as this one, right? Now, use your calculator, tell me what happened to the rate. Maybe, well, you don't need a calculator.
No, just like that.
Huh?
Increased by a factor of 2.
It increased by a factor of 2, didn't it?
We know that because what you told us earlier.
It doesn't always have to be. Doesn't always have to be. In that example on the slide, it was. Okay, so my rate doubles between 1 and 3, doesn't it? 2 to the what power equals 2?
1 first.
Okay, so this reaction is first order with respect to F2.
Right.
Okay.
Yes. With respect to F2, it's first order.
What do you mean by that?
He's gonna get to
Let's go back to our data. Nothing about the ClO2 is affecting the rate.
No.
Right?
Okay.
This is doubled. So I wrote down a 2. My concentration doubled. By doubling the concentration of F2, I doubled the rate. This number is twice as big as this one. So I wrote down another 2. 2 to what power equals 2?
1.
1. So it is first order with respect to F2.
Okay.
Okay?
First, so the order is
The order is
the
the order tells us how a change in concentration of that reactant will affect the rate. What if I doubled the concentration and there was no change in rate?
That would mean that you double the ClO2, right?
No. Let's say
That'd be 0.
if I double the concentration and there is no change in rate, 2 to the what equals 0. Then it would be 0 order with respect to that reactant.
Oh.
Okay, I get how you did it.
Oh, okay.
Huh?
I get how you did it, but I don't get what it means.
It tells us how changing the concentration affects the rate.
Okay.
So if something's 0 order, that means that you're changing.
And I can increase the concentration all day long and the rate's not going to go any faster.
But if it's, for example, if it's first order, does that mean?
No, it's their concentration.
And if it's first, okay, you said it's.
If it's first order, then I know, if it's first order, then I know doubling the rate or doubling the concentration will double the rate.
Okay, but if it's second order, then what
It
I
would go to 4, 4.8.
Okay, let's say we have a reaction where we're second order with respect to one reactant.
Yeah.
What can I expect from the rate?
4.
Quadruple.
I can expect the rate to go 4 times faster.
Okay.
Then it's second order.
So it's just telling us how much it's telling us exactly what you said. Okay.
Yes, it's telling you exactly what I said.
Well,
I couldn't have said it better myself.
no.
You're just mindful.
Was, I don't know.
So if something were, like the rate were to triple, like, were to.
If the rate was to triple, he says.
Yeah, the rate.
What?
Actually, the rate goes over here, but if the rate was to
Yeah, I was
triple,
like, wait, what? If the rate triples, then 2 to the what?
why don't we figure out the order with respect to our other reactant in this problem? How do you want to do that?
1.2 to the, wait, no.
I want to look at 2 trials where F2 is constant.
Then look at
1 and 2.
1 and 2.
Let's look at 1 and 2. Okay.
Okay.
That way, we only want one variable. So we want the other thing held constant, so we know that this isn't affecting the rate, just my change in ClO2. So here, what am I doing?
Quadrupling.
I quadruple. So I increase the rate, or the concentration, I gotta watch my language. I increase the concentration by a factor of 4. I don't want to confusicate you. Gotta be very precise about my language. Okay. Precision or accuracy? What's he talking about? What happened to my rate between 1 and 2?
It quadrupled.
It quadrupled 2?
Yeah.
So,
Or
4 to the what equals 4?
quad.
So it's first order in both, with respect to both reactants, isn't it?
Yeah.
So,
Clear.
First order in respect to.
It's first order with respect to both reactants. Now I can write my rate expression. Clear.
Yeah.
Yes.
What if they're two different orders? Would we add them up?
Then, excellent question. What if there are two different orders? Then we want to refer to the overall order. What's the overall order for this reaction?
1,
No,
2.
it's second order overall. Just add them up. If one was first order and the other was second order, the overall order would be third. Does that answer your question? Maybe kind of, sort of? Like, I just went through this. So, this is basically what we just talked about. Here's some more data. Let's practice. Got to be precise with my language. You can know.
Practice.
All right. What is the order with respect to A?
First order.
We have two reactants, A and B, going to produce something. Probably AB.
Respect to A is first order.
Okay, how are you going to figure that out?
Because use the first and third trial because the.
No, I don't want to use the first and third trial.
The first and second, I mean.
No, I don't want to use the first and second trial to figure out A.
Third and the second and third.
Let's use the second and third, so B is held constant. Then I know
Oh, I didn't.
A is affecting the rate.
That makes sense. So it's not, my bad. It's.
Okay, so my concentration of A doubles between the second and third trial. So concentration doubles. What happens to the rate between the second and third trial?
Stay the same.
No change, so it is
Zero order.
zero order with respect to A. Write it in, 0 order for A.
Zero order with respect to A. The other one.
The other one,
Is.
what trials do we want to look at for the other one?
1 and 2. And then.
Why 1 and 2?
Because it's on constant.
A is can
Because A is constant. So here we double the concentration. This one's A, this one's B. What happens to the rate
It doubles.
between 1 and 2?
double.
It doubles.
So that's first order in respect to A.
So it is what order?
First order.
First order. What's the overall order of the reaction?
One.
One.
It's first order overall.
Well, what is the overall? Like, what happens if one was second order, one was first order?
We.
That would be third order overall. Add. Okay, I want one more thing on this slide.
Okay.
What is the rate law for this reaction?
The rate law, it is.
Rate law is going to,
K
what's the rate law expression?
K.
rate.
Rate.
Relationship.
This is important. By the way, on the free response, on the kinetics and equilibrium sections, there's always some easy questions. Always. It'll ask you what the rate law is. Rate equals
K.
K,
A. Concentration. of
concentration of
A
A,
raised to 0.
X.
Times concentration of B raised to 1.
Now, what happens when I multiply by something raised to the 0?
It's zero.
It's 0. Do I need it?
No.
Then let's leave it out of our rate law. It doesn't need to be there.
K, concentration of B in first order.
Can I drop the 1? It's a given, isn't it? There. There's our rate law for this reaction. We just got 1 point on the free response question.
Awesome.
Actually, to get there, we probably got several, because you had to figure out the orders. There's a couple questions that probably lead up to this.
So you get, wait, so there are questions just like that on the.
Yes. What is the rate law for this reaction? And they'll give you a table of data. You've got to figure out what's first order this, second order this.
Sweet.
Yeah, I mean, it's going to get a little more complicated, but that's a start.
So even if they were outside, that's like, more maybe leading up to the other one.
Yes, you better get at least half of them. That's right. Get all the easy stuff. Stop.
Half.
Stop with one.